Problem 3. Suppose that the average measure of air pollution in such view is given by the formula P of t equals t squared divided by square root of t squared plus 36. T is time in years measured from 1980. The question asks for how fast was this measure changing in 1988. For the year 1980, that means the t equals 0. How fast was this measure represented by the derivative of the p or the measure of air pollution with respect to time? We are looking for this derivative and calculate where t equals 8 because the year 1988, the value of the t gonna be 8 because 8 years after the year 1980. To find the derivative of the p function, which is in the quotient form, we're going to use the quotient rule. Refer to the quotient rule. When you use the quotient rule to find the derivative, we call the derivative or dp dt using the notation that I always use as the high for the numerator, low as a denominator expression. The formula is low d high minus high d low. Draw the line, low squared. So we're gonna need the high d high, low d low expressions to bring it back into the quotient rule or the quotient formula. On the side notes, I'm gonna make a list. My high function is t squared, and my low function is square root of t squared plus 36. And I'm gonna find the derivative of the high function or the d high, which is 2t. For the low function, I will write it as the power form. So I have t squared plus 36 to the power 1/2. To find the d low or the derivative of the low, I'm going to use the general power rule because this is a composite function that has the power 1/2 as a power of the expression t squared plus 36, where my n is 1/2 and my gx, my gt is the function t squared plus 36. So to apply the general power rule, the formula is n multiplied by the quantity for the function g to the power n minus 1 and multiplied by the derivative of the function g. Since the g of t, so I put a note here, my n is 1/2, my g of t is t squared plus 36. So my g prime or the derivative of the g is 2t. So I bring it back into the low or the derivative of the low function. N is 1/2 expression t squared plus 36 to the power 1/2 minus 1 and then multiply by the g prime, which is 2t. After that, I'm going to simplify as much as I can. So 2 and 2 reduce and the power 1/2 minus 1 becomes negative 1/2. So I write in the better form by writing t in the front and then multiply by the quantity t squared plus 36 to the power negative 1/2 as the d low. I got all my prep work ready. And I'm going to bring everything back into the quotient rule to find the derivative of the p. So for my the low expression is the quantity t squared plus 36 to the power 1/2. So instead of writing the radical, I'm going to write as a 1/2 power. And then the d high is the expression 2 times t minus the high function, which is t squared, multiplied by the d low, which is t, multiplied by the quantity t squared plus 36 to the power negative 1/2, all divided by the denominator, which is low squared, or the quantity, the square root of t squared plus 36 raised to the second power. And next, I'm going to simplify. When I simplify, the bottom is easier to take care of because the power 2 and the radical will take care of each other and comes to the term just t squared plus 36 for the denominator. And for the numerator, I see t and t as a common factor. I write it as t multiplied by the factor here. I still have 2 as an extra term. So 2 times t squared plus 36 to the power 1 half, and then minus t squared multiplied by t squared plus 36 to the power negative 1 half. And then for our convenience, I'm going to write it as multiply by the reciprocal instead of the quotient, or divide by t squared plus 36, or write it as t over t squared plus 36 as one group. And in a bracket, I will work on simplifying the expression inside of it. The power negative means the reciprocal of the power positive. So I write the negative power as the positive power, but in the reciprocal form. And then I will find the common denominator as the quantity to the power 1 half divided by 1. The common denominator gonna be the quantity t squared plus 36 to the power 1 half. So I multiply the top and bottom of the first term by the quantity to the power 1 half, quantity to the power 1 half. And the front expression still remain as the quotient t over t squared plus 36. And after you multiply top and bottom of the first term by the quantity t squared plus 36 to the power 1 half, I will have the t squared plus 36 to the first power subtracted by t squared. Next, I'm going to simplify the numerator. For the numerator, as you see, multiply 2 inside. We have 2t squared plus 72 minus t squared. So then the simplified form after this gonna be t divided by the quantity t squared plus 36. And then in a bracket, it becomes just t squared plus 72 and all divided by the quantity t squared plus 36 to the power 1 half. And this is the general term for the derivative of the P, or the measure of the air pollution with respect to time. And what we have to do next, we're going to replace the T with the value 8, because that's what we are looking for the rate of the measure of air pollution in the year 1988. So for this case, for the dp dt, evaluate when t equals 8. Wherever you see t, you're going to replace with the value 8. 8 divided by 8 squared plus 36. And then in the bracket here, we have 8 squared plus 72 divided by the quantity 8 squared plus 36 to the power 1 half. And the answer is 1.088. Then unit would be the unit of the measure of pollution divided by year.